Hello, in this video we're going to look at the idea of counting again, only we're going to look at two very special kinds of counting that are used on some occasions. And they're called permutations and combinations. We have to be careful with these because they have certain conditions that have to be met in order to use them. But if we do meet those conditions, they are an easy way of doing some counting for us. So let's go ahead and get started on those two ideas, permutations and combinations. So again, these are two special kinds of counting that can be used on some occasions. And I'm going to start by giving you a definition, which probably isn't going to make much sense to begin with. Then we'll go through an example, and then we'll figure out what the notation is and how to use it on the calculator. So a permutation is the number of ways that a certain number of items, n items, can be chosen r at a time. And for permutations, we say that order is important. Remember in the last section we talked about order being important or not, and this is where it's really going to come into play with the idea of permutations and combinations. So here's an example. Let's say you have 8 numbers to pick from, and you want to make a 3-number combination, and no repeats are allowed. How many possible combinations are there? And we say that order is important. Okay. So if we go back to just using our slot method, we've got a 3-number combination, and we want to know how many possible combinations there are, and we said no repeats are allowed, and the order is important. So we say that there are 8 numbers that could go here. Once I choose one of the 8 numbers, since no repeats are allowed, there's only 7 numbers that can go in the second slot. Once I've chosen these two, there's only 6 numbers left that could go there. And so I'm going to multiply those together, 8 times 7 times 6, and that's going to give me 336 possibles. And I don't have to worry about overcounting because the order was important. So if I used 1, 2, 3, oops. So if I use 1, 2, 3, that is different than 3, 2, 1, even though it's the same numbers. All right, so I haven't done any overcounting. All righty, so there is how we would do it using the slot method. And you look at that and say, well, why can't we use the slot method? The answer is you can always use the slot method. All right, but there are times where it might be a little easier to do permutations instead. So there's what we have. Now I need to look at one other thing before I give you the notation for a permutation, and that's the idea of factorials. And here is a factorial. If I have a number like 5, and I put an exclamation behind it, that doesn't mean I'm really excited about number 5. This exclamation point is what we call a factorial. And what it tells us to do is it tells us to take the number 5 and multiply it by all the whole numbers less than it until you get down to 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. 15 factorial would mean 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right? And you can see that these numbers get really big really soon. Pardon me. Okay, so just a couple of other little things. 1 factorial is just 1. And 0 factorial is also 1. There's some reasons for that. We're not going to go into those in this course. But those are just some other interesting things to have. Now, the reason we brought up the idea of factorials is because if we look up here, we can see that we've got 8 times 7 times 6, which looks like it's part of a factorial. And that comes into play when we do the notation. Hold on real quick. I got to get a drink. All right. So here's the notation. We say that a permutation of n items choosing r at a time is equal to n factorial over n minus r factorial. This is the notation that the book uses. However, if you do it on your calculator, this is the notation that the calculator uses. But they both mean the same thing. You're doing a permutation of n items and you're choosing r at a time. So if we look at that in terms of what we were doing up here, all right, we had 8 numbers and we were choosing 3 at a time, so we had a permutation of 8, choose 3, which according to our formula is going to be 8 factorial over 8 minus 3 factorial, which if we write that out, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and 8 minus 3 is 5, and 5 factorial is 5 times 4 times 3 times 2 times 1. And notice, since we have all products here in numerator and denominator, these pieces of the products are going to cancel out, and I'm left with 8 times 7 times 6, which is exactly what I had up here. Now let me show you how to do that on the calculator. If you go to your calculator, alrighty, and you go to your math menu, and you go over here to the right-hand side to PRB. That stands for probability. Notice that one of the options down here is NPR. That's not the radio station. That's a permutation of N choose R. And notice the way it's got it in here is it wants the N first, and then it wants the R last. And the way we actually have to plug that in is we have to go back to our main screen. So I hit second quit. And we're going to choose the 8 numbers that we had. Okay. And then we're going to go into math. We're going to choose PRB. I'm going to go down to permutation, choose that, and then I'm going to say it's 8, choose 3. And I'm going to hit enter, and notice I get the exact same value as when I did 8 times 7 times 6. And that's how you do permutations on the calculator. Of course, it has to fit all of the conditions of a permutation. It has to be we're doing n items, r at a time, and that order is important. But that's the idea with permutations. Now, the other special kind is the idea of combinations. And it looks very similar, the number of ways that n items can be chosen are at a time. However, for combinations, order is not important. So if we're setting that up, what we're going to do is we're going to say, for our example, if you're playing the pick lottery, alrighty, you can choose 6 numbers from 1 to 44 without repetition. And the order in which the numbers is chosen is not important, as long as you have the right 6 numbers. How many possible ticket combinations are there? Well, if we do that using our slot method, we've got 6 numbers to choose from, or six numbers to choose. And for the first number to choose, there are 44 possibilities. Alrighty. Now, we do not choose a number more than once, because once a ball pops up on those little machines, they don't come back up. So once we've chosen one of those numbers, now there's only 43 numbers that could go in the second slot. There's only 42 numbers in the third slot, only 41 in the fourth slot, 40 and 39. And I can multiply all of those numbers together. The only problem is that this is overcounting. It overcounts. And the reason it overcounts is, let's say we chose the numbers 1, 2, 3, 4, 5, and 6. It doesn't matter what order we choose those in. So if I chose 1, 2, 3, 4, 5, and 6, that would be counted as one of these possibilities. But if I chose 2, 1, 3, 4, 5, 6, that gets counted as a separate possibility, but it's not really a separate possibility. So I'm overcounting here. So what I've got to do is I've got to divide out the overcount. And I have to figure out what the overcount is. In order to do that, what I'm going to do is I'm going to say, all right, I've got 6 numbers here. And I'm going to say, of those 6 numbers, any 6 of them could go in the first slot. So I'm going to actually look at this in slots again. So any of those numbers could go, any of those 6 numbers could go in the first slot. Once I've got 1 in the first slot, there's 5 that could go in the second slot, 4, 3, 2, and 1. And if I multiply those together, that'll give me the number of ways that I could put the numbers 1, 2, 3, 4, 5, and 6 in different orders. And all of those would be counted differently here, but they're not different, so I have to divide those out. So if I do that now, let's see what I get. 44 times 43 times 42 times 41 times 40 times 39 gives me a very large number, 508,251,7440. So what is that? 5,082,517,440 divided by this overcount, which is 720. So there's 720 ways that I could put things together that they're actually the same. And when I divide those two numbers, 508,251,7440 divided by 720, I get 705,9052. So about 7 million different combinations. That's why I don't play the lottery. The odds are just too poor in winning. So what's the notation on that? Well, the notation is very similar to the notation up above, but instead of P's, we're going to have C's since we're dealing with combinations. So it'd be the combination of n items chosen r at a time, and that could also be NCR, like that. And what this means, this is a little different because it's going to start out the same. We're going to have n factorial over n minus r factorial. But we need one more piece. We need that overcount piece. And notice the overcount piece is just going to be r factorial. So we need to add that one last piece in. So that's the notation that we're going to use for combinations. And if we do that for this example, we have a combination of 44 letters or 44 numbers chosen 6 at a time. If I do that on the calculator, I would plug that in as 44 NCR 6. And let's go to the calculator and just do that. So I'd plug in 44. I'd go back to that math menu, go back to PRB, go down to N choose R, and notice there's factorial right there. Okay, they're all underneath that probability one. And I'm going to choose 6 of those, and notice I get the exact same number. Alrighty, so that is combinations. Now let's go through a couple of examples and see if we can choose whether they are permutations or combinations or neither. So examples. Specify the number of ways to perform the task described and give your answers using this notation, and then find the numeric answer. So let's say that the following happens. Mulder will read the files on 3 unsolved cases from a list of 17. He doesn't care about the order in which he reads the files. So notice we have a list of a certain number, and we're choosing a certain amount from that list. And the important thing here is that the order doesn't matter. So the fact that we've got a certain number and we're choosing something out of that tells us we've got a permutation or a combination. The fact that we don't care about the order means that we have a combination. Because if you look back at your definitions, a combination is when the order was not important. Okay, so we've got a combination of 17 files, and he's going to read 3 of them. So if we go to the calculator, we'd plug in 17 NCR 3, and we get there are 680 different ways that he could do that. Okay? Next one, the manager of a baseball team has already chosen the first, second, fourth, and ninth batters in the batting lineup. He has selected 5 others to play and wants to write their names in the batting lineup. So, first of all, he's selecting 5 folks to play. Boy, I wrote this poorly, didn't I? So, manager of a baseball team has chosen first, second, fourth, and ninth, and he has selected 5 others to play. So we've got 4 slots chosen, and okay, I see what I'm saying. And we've got 5 others that are going to take those other 5 slots. Alrighty? So, in this case, we've got 5, and we're choosing 5. Again, that's still going to be a permutation or a combination. But now we need to figure out which it is. And we need to ask, does order matter? And for those of you that are baseball fans, yes, it does matter. If you have somebody batting third, that's going to be a lot different than if they're batting 8th. Alrighty, so our answer to does order matter is yes. And since order matters, that means it's going to be a permutation. So since we've got a permutation, we've got 5 players, and we're choosing them for 5 different slots, which would be, if we go to the calculator, 5, that gives us 120 different lineups that could happen with those 5 players. Alrighty? Now notice what happens if we do that in factorial is we get 5 factorial over 5 minus 5 factorial, which is 5 factorial over 0 factorial. But 0 factorial is equal to 1, so we just get 5 factorial. And if you do that on your calculator, you'll notice you get the same thing. So if I put in 5, and I go to the math menu, and I go over to probability, and I choose factorial, 5 factorial is 120. Okay? Now, number 3 says 10 magazines are competing for 3 identical awards for excellence in journalism. No magazine can receive more than 1 award. All right. So the key here is we've got identical awards. And we've got 10 magazines that are going to win those 3 awards. So we have to ask, does order matter? And our answer, since they're identical awards, it doesn't matter who got the first one, the second one, or the third one, because they're all the same. So our answer would be no, which means we've got a combination. So we'd have a combination of 10, choose 3. And when we do that in the calculator, we get 120. Now our last one's a little trickier. It says NASA wants to appoint 2 men and 3 women to become residents of an orbiting space station. The finalists for these positions consist of 6 men and 8 women. In how many ways can NASA make this selection? Well, what we have to do is we have to break this down into the genders. All right, we're going to have the men and we're going to have the women. And then we have to ask, does order matter? Well, if you're getting chosen to go, it doesn't matter if you got chosen first, second, third, whatever. So the answer is no, which means we've got a combination. But in this case, we've actually got 2 different combinations. We've got the men combination. There are 6 men, and we're going to choose 2 of them. So we'd have a combination of 6 choose 2 for the men. Different ways we could do that. And we've got 8 women, and we're choosing 3 of them. And then once we have the men and the women, we're going to multiply those choices because of the fundamental counting principle. Okay? And what we're going to get, let's see, let's do that a piece at a time. So if I choose 6 combination 2, that gives me 15 different ways I can choose those 2 men, and 8 combination with 3. There's 56 different ways I can choose the women, which means that there are 56 times 15 ways to choose both of them, so there's 840 total ways. Alrighty? Now one last note. One of the problems that we did back in 13.2 was this problem, the license plate problem. And if you look at that one, is there a way that you could use combinations or permutations? And the answer is no. And the reason why is because we can reuse stuff and we're not using it up. If you didn't allow repeats, then you could set that up sort of the same way that you're setting up this back here. All right, but anytime you have these repeats like this, then you can't use combinations or permutations. Okay, same thing up above. You have repeats being allowed, so you can't use a permutation or combination. But notice this one down here, where repetition is not allowed, that's the same as a permutation of 10, choose 4. Alrighty, so be careful on those. That's why I said at the very beginning of this that these are special kinds of counting. They only work if repetition is not allowed. Okay? So hope that helps.